Imagine if the secret to building muscle was just hiding in the mustard you put on your Sunday roast.
Right.
And, imagine if the key to cellular longevity was just locked inside the bark of that pine tree sitting in your backyard right now. I mean, you would probably look at your pantry and the natural world around you a whole lot differently.
Oh, absolutely. It really changes the entire paradigm. We tend to think of modern medicine and nature as these two, completely separate domains.
Yeah, totally.
But the line between a wild weed and a potent biological trigger is actually remarkably thin.
Well, welcome to this deep dive.
Yep.
Today, our mission is to trace that exact journey. We're going to explore the fascinating hidden power of plant materials. We're asking the big question for you today. How does a plant go from a raw botanical in the wild to a highly engineered substance that can actually mimic human hormones?
Right, which is wild to even think about.
It really is.
Yeah.
So we'll look at the complex chemistry hiding inside the Caribbean pine, break down the extreme industrial physics like the intense stuff required to pulverize these plants so our bodies can actually absorb them.
The milling process, yeah.
Exactly. And finally, we'll examine the darker side of things. Like what happens when we engineer these natural particles so well that they trigger violent rebellions in the human immune system.
Yeah, and we are pulling from a really fascinating stack of research for you today. The notes you've sent over cover everything from clinical sports pharmacology studies on plant steroids to ethnopharmacological reviews of pine species.
It's a huge variety.
It is, and it goes straight through to engineering manuals on industrial powder milling and clinical immunology data from FAIR and the AKI. It's a massive web, but it all connects perfectly.
Okay, let's unpack this because we have to start with the mustard. When I was reading through the notes, I literally had to stop and do a double take.
I don't blame you.
We're talking about plant steroids having a biological, like actual muscle building effect on mammals. I didn't even know plants had steroids.
They absolutely do, yeah. They are called brasinosteroids. And in the plant kingdom, these are simply the hormones that promote growth.
Okay.
They basically tell the plant to stretch out its stems, grow leaves, and develop. But the question that researchers asked was, well, what happens if a mammal ingests these specific plant hormones?
Right.
So there's this fascinating study published in the FAZB journal by a researcher named Esposito and his team that looked at exactly this. They isolated a specific brasinosteroid found in mustard plants called homobrasinolide.
Or HB for short, right.
Exactly, HB. And they fed it to rats for 24 days.
And from what the sports physiotherapy blogs were saying, these rats essentially, they got swole.
They did.
But how? Like, what is the actual mechanism there?
So the researchers observed a massive anabolic response, and anabolic just means building up tissue. The rats had increased lean body mass, and their gastrocnemius muscles, the primary calf muscles, grew significantly. But it wasn't just size, it was performance.
Which is the crazy part.
Yeah. They measured a 6.7% increase in lower extremity grip strength.
Almost 7% just from a plant extract. That's insane.
Right. And when they looked at the muscle tissue under a microscope to figure out why they were stronger, they saw a physical increase in the size and number of type II and type II muscle fibers.
Okay, remind me and the listener what those specific fibers do, because I always get them mixed up.
Sure. So think of the difference between a marathon runner and a heavyweight lifter. Type I fibers are your slow twitch endurance fibers. They keep you going for miles.
Okay, so a marathon runner.
Exactly. Type II and II are your fast twitch fibers. They are responsible for explosive power, heavy lifting, sprinting, that kind of thing.
Oh, wow.
So the homobrasinolide was specifically targeting and building the exact fibers associated with brute strength.
That's wild. But reading through the methodology, there was one detail that made me wince.
The castration.
Yes. They didn't just test this on healthy, normal rats. They put some on a high-protein diet, which makes sense. But they also tested surgically castrated rats. Why on earth would they do that?
I know, it sounds harsh, but the castrated rat is a classic essential model in pharmacology.
Really? Why?
Because when you are testing a potential steroid, you have to remove the animal's natural testosterone production from the equation. If a normal rat gets stronger, you might wonder, well, did the plant extract build the muscle, or did it just cause the rat's own testes to produce more testosterone?
Oh, I see. So you wouldn't know the actual cause.
Right. By using a castrated model, you establish a zero baseline. If that rat still builds muscle, you know definitively that your specific plant compound is directly driving the growth.
And it still worked.
It worked beautifully. The homobracinolide restored those androgen-dependent tissues and grew those fast-twitch muscle fibers even in the complete absence of natural testosterone.
Okay, so the obvious question here, if I go eat a hot dog completely slathered in mustard, am I accidentally stumbling into a natural steroid cycle? Like, are professional athletes going to start chugging bottles of mustard instead of protein shakes?
Please do not start chugging mustard.
I mean, I love mustard, but
You would have to consume an absolute mountain of the raw plant to get anywhere near the concentrated dosage used in this clinical setting.
right.
But the real breakthrough here isn't just about athletes getting stronger, it's about what didn't happen to these rats.
What do you mean?
Well, when humans take synthetic anabolic steroids, they often suffer severe androgenic side effects. And androgenic refers to the development of male sex characteristics.
So like hair loss and stuff.
Exactly. Traditional steroids cause hair loss, severe acne, prostate enlargement, and they suppress your body's natural hormone production.
Vikings.
But the homobracinolide triggered the anabolic muscle-building response with virtually none of those androgenic side effects.
Wait, really? None.
Yeah, in Petri dish tests, it didn't even bind directly to the body's primary androgen receptors. It basically found backdoor into the muscle-building process.
So it's giving you the muscle without the biological collateral damage.
That is the holy grail. We're looking at a massive potential drug target for treating age and disease-associated muscle wasting.
Oh, that makes so much sense.
Imagine a cancer patient undergoing chemo who is losing their muscle mass, or an elderly person becoming frail. If we can refine this plant steroid, we could potentially rebuild their strength safely without subjecting their bodies to the toxic side effects of synthetic steroids.
That is incredible, and it completely changes how you look at the mustard plant.
Hmm.
But mustard isn't the only botanical packing a hidden punch. The sources also spend a lot of time on pine pollen.
Yes. Traditional Chinese medicine has utilized pine pollen for centuries. It's typically taken as a raw powder or steeped in a tincture, and modern chemistry is finally catching up to why it actually works.
So what's the science there?
Pine pollen actually contains phytoandrogens. These are plant-based compounds that are structurally very, very similar to mammalian testosterone.
Yeah, the clinical notes mention people will cycle this, like taking it 5 days on, 2 days off to support their energy, stamina, and prostate health.
Right.
And apparently it's heavily loaded with antioxidants, too.
Very specific antioxidants, actually. It contains high levels of an enzyme called superoxide dismutase, or SOD.
Okay, SOD.
Think of SOD as a highly specialized cellular cleanup crew. When your cells produce energy, they create a lot of oxidative waste.
Like free radicals.
Exactly, free radicals that damage DNA and accelerate aging. SOD sweeps through and neutralizes that oxidative stress before it can cause structural damage.
It's just wild to think of pollen as a performance enhancer, but what really stood out to me in the research is that pine pollen is just one tiny speck of the actual tree.
Oh, absolutely.
If you zoom out, the whole pine tree is effectively a complex pharmaceutical factory. And the ethnopharmacological review you mentioned earlier, it really zoned in on one specific tree, Pinus occidentalis.
The Hispaniola pine. Yeah, it's a species completely endemic to the mountainous regions of the Dominican Republic and Haiti.
Right.
They call it Pinot Criollo.
Yeah.
And it serves as the perfect case study for how indigenous traditional medicine often heavily anticipates modern phytochemistry.
Yeah, the people of Hispaniola use almost every single part of this tree.
Yeah.
They brew a hot tea out of the bark, the needles, and even the tender sprouts of the pine cones to treat severe coughs and respiratory infections. And they take the resin and use it for wound healing, or they make this turpentine-based quaba soap for skin infections.
And when we look at the molecular structure of those tree parts today, the traditional uses align perfectly with the biology.
So the science backs it up.
Completely. Let's look at the bark first. Pine bark is this incredibly dense matrix of structural polysaccharides, lignin, and polyphenols. In fact, the bark of this specific pine contains 1.5 times more polyphenols than the needles do.
Polyphenols being the chemical compounds that reduce inflammation and act like heavy-duty antioxidants, right?
Correct. The bark is rich in procyanidins. You might see them standardized in modern supplements under the name pycnogenol.
I think I've seen that at the pharmacy, yeah.
They are incredibly effective at promoting nitric oxide production, which relaxes your blood vessels and improves overall vascular health. But the bark also holds a compound called pinosylvin.
And here's where the notes got really intense, because pinosylvin isn't just about blood flow. It's being actively studied for cancer therapies.
It is. Pinosylvin is a type of compound called a phytostilbene. Researchers ran in vitro studies, meaning test tube studies on human oral cancer cells.
Okay.
And they found that pinosylvin aggressively suppresses something called the MMP2 pathway.
Break that down for me. What exactly is the MMP2 pathway?
MMP stands for matrix metalloproteinases. They are essentially enzymes. Imagine cancer cells are trapped inside a room of healthy tissue.
Okay, I'm picturing it.
To spread or metastasize, the cancer needs a way to break through the walls of that room. MMPs are like molecular machetes that the cancer cells use to chop through the surrounding tissue matrix so they can escape and migrate to other parts of the body.
So they use MMP2 to just hack their way out.
Yes. And what pinosylvin does is suppress the production of those machetes.
Oh, wow.
It basically cuts the brakes on the cancer's ability to clear a path, effectively trapping the cells and reducing their ability to metastasize.
Okay, hold on. Let me push back on something here.
Sure.
If the bark is packed with so many more polyphenols than the rest of the tree, and it holds this incredible heavy-duty, cancer-trapping, vascular-repairing compound, why on earth are traditional healers wasting their time boiling the needles for tea when someone gets sick?
That's a fair point.
Like, why wouldn't you just always use the bark?
It is a great question, but you have to consider the immediate physiological need of the patient. The bark provides incredible heavy-duty, long-term cellular defense.
Right.
But if you are sitting there with a severe respiratory infection hacking your lungs out, you don't care about long-term vascular repair. You need to be able to breathe right now.
Okay.
Yeah.
You need immediate symptom relief.
Exactly. And that is what the needles provide. The needles contain essential oils that are packed with volatile monoterpenes.
So it's a completely different chemical profile.
Totally different.
Yeah.
When we look at Pinus occidentalis, it has an unusually high proportion of a specific sesquiterpene called germicrene D. It makes up about 22% of the essential oil profile, alongside compounds like alpha and beta pine.
And what do those do?
They are powerful, fast-acting bronchodilators and antimicrobials. Volatile just means they evaporate easily.
Oh, so they turn into vapor.
Right. So when you take those needles and steep them in boiling water, the steam physically carries those terpenes up out of the cup and directly into your respiratory tract.
That's genius.
They hit your airways, relax the smooth muscle tissue to open up your breathing, and immediately start fighting the localized bacterial infection. Bark is for the long game, needles are for the immediate rescue.
That makes so much sense. It's like a built-in pharmacy with different delivery methods. But there is a massive disconnect here for me.
What's that?
If I want the systemic benefits of the bark, or if I want that homopersinolide from the mustard plant, I can't just go out to my backyard and start gnawing on a tree trunk. My stomach isn't a chemical refinery.
No, it is not. And this is the invisible bridge between raw nature and modern medicine, the physics of bioavailability.
Right.
You can have the most miraculous plant compound on Earth, but if your body can't absorb it, it's basically useless. To get these benefits, we have to extract them, and that requires mechanically pulverizing these plants into ultrafine powders.
Right. The engineering notes from Ceramics really got into the weeds on this.
Yeah.
Let's talk about industrial milling, starting with dry ball milling, because it sounds incredibly violent.
Oh, it is brute force physics. Imagine a large rotating cylindrical drum. You fill it with grinding media, usually heavy steel or ceramic balls.
Okay.
You dump your raw botanical material in, seal it, and spin the drum. The kinetic energy of those heavy balls constantly cascading, dropping, and impacting the material physically crushes it into a powder.
And the notes say this dry method can reduce particles down to a D50 of about 5 micrometers. Explain D50 for us, just to be clear.
D50 is a median measurement. It means that exactly 50% of the particles in your resulting powder are smaller than that number, and 50% are larger.
Got it.
So a D50 of 5 micrometers means your average particle size is 5 millionths of a meter. For context, a single human red blood cell is about 8 micrometers across.
Wow.
So we are crushing tree bark down to the size of a blood cell.
Which seems unimaginably small.
Yeah.
But apparently it's not always small enough, especially if you were trying to make highly soluble pharmaceutical or something crazy precise like a lithium-ion battery slurry.
Yeah,
If you want to go smaller than 5 micrometers, dry milling just stops working, right?
It does, yeah, because of static electricity.
Yeah.
When you fracture dry powder into the submicron or nanometer range, you are exposing massive amounts of new surface area.
Okay.
These tiny particles generate static charge and extremely high surface energy. They desperately want to stick back together to lower that energy state. It's a process called reagglomeration.
So they just clump up.
Right, you can spin the drum all day, but the powder just forms a solid cake.
So how do you beat the static?
You switch to wet ball milling. You add a liquid, medium water, ethanol, sometimes specialized solvents to create a suspension.
Okay.
The liquid acts as a buffer. It neutralizes the surface charges and keeps those microscopic particles physically separated so the grinding media can continue to smash them down into the nanometer range.
Okay, I came up with an analogy for this when I was reading it. Tell me if this works.
Let's hear it.
Wet ball milling is essentially like trying to crush a bunch of rocks in a kitchen blender, but you fill the blender with water first.
Right.
The water keeps the rock dust from sticking together into a giant clump of mud at the bottom. But spinning all that gritty rock water is going to absolutely destroy the metal blender blades.
That is a brilliant visual, and it highlights the exact engineering nightmare of wet milling.
Yeah.
Because that liquid slurry essentially becomes fluid sandpaper. If you use standard stainless steel balls in a wet mill, the constant friction and abrasive corrosion will rapidly degrade the steel.
Which sounds bad.
Very bad. The steel wears away, and suddenly your highly precise botanical medicine is contaminated with toxic metal shavings.
Which totally defeats the whole purpose.
Yeah.
So what's the workaround? You have to use harder balls.
You have to upgrade your grinding media to materials that are nearly indestructible. Engineers use materials like baguette or yttria-stabilized zirconia.
Zirconia, like the fake diamonds.
Similar material, yeah. Zirconia is incredibly dense, vastly harder than steel, and chemically inert. It can withstand that harsh liquid sandpaper environment without shedding contaminants into your product.
Wow. And then there's the third method that doesn't even use balls at all. Jet milling.
Jet milling is a completely different approach. Instead of physical grinding media, you inject high-velocity compressed air or superheated steam into a specialized chamber.
Okay.
You introduce your raw material, and the extreme vortex of the air causes the particles to violently collide into each other. They pulverize themselves through hypervelocity impacts.
That sounds intense.
It is. If you use steam, the energy is so high you can achieve particle sizes well below 1 micrometer.
So for you listening to this, the reason we are detouring into industrial physics is because this precise milling is the gatekeeper.
Absolutely.
It is what separates a cheap, useless botanical powder that just passes right through your digestive tract from an ultrafine, highly bioavailable supplement where those brassinosteroids or polyphenols can actually enter your bloodstream and interface with your biology.
It is the necessary mechanism of delivery. We have to break nature down to the cellular level to use it.
But there is a massive downside to all of this, because when we process biological materials into these ultrafine airborne powders, or when nature does it for us,
Yeah.
human biology doesn't always react by building muscle or opening up airways. Sometimes, when these microscopic plant proteins hit our system, the immune system violently rebels.
And this brings us to the dual nature of botanicals. The chemistry of a plant is neutral. It is our biological response to that chemistry that dictates whether it acts as a medicine or a poison.
Let's talk about the dark side of this, starting with the pine tree we were just praising earlier. We just talked about pine pollen as a testosterone-boosting supplement.
Right.
But for a huge portion of the population, pine pollen is a notorious, miserable allergen.
Yes. In the spring, pine forests release staggering, visible clouds of pollen into the air to reproduce.
I've seen that. The yellow dust covering cars.
Exactly. Because these grains are so small and buoyant, they travel for hundreds of miles. And when you inhale them, your immune system might misidentify that harmless plant protein as a dangerous invader.
This triggers what the clinical notes call a localized IgE response. Unpack IgE for us.
IgE stands for immunoglobulin E. Think of IgE antibodies as your immune system's localized bouncers.
Okay, bouncers.
They sit in your mucosal membranes, your nose, your eyes, your throat. When they spot the pine pollen, they grab it and signal the body to release histamine.
Oh, hence antihistamines.
Exactly. The histamine causes the blood vessels to swell and leak fluid, trying to physically flush the invader out.
So that's your classic hay fever.
Yeah.
The itchy, watery eyes, the sneezing, the coughing. It's annoying, but it's localized.
Right. The bouncer is just handling a problem at the front door.
Wait, let me clarify something right here because it comes up every December.
Mhm.
What about the Christmas tree allergy? People are constantly complaining that they're allergic to the pine tree they just set up in their living room.
Yes. It is one of the most common botanical myths. Pine pollen is strictly a spring phenomenon. The tree is not producing pollen in the winter. If you bring a live Christmas tree into your home and start sneezing, you are almost certainly not allergic to the pine tree itself.
Then what's triggering the reaction?
You are reacting to fall weed pollens like ragweed or microscopic mold spores that just happen to be clinging to the sticky bark and needles of the tree when it was sitting out in the farm or the lot.
Oh, wow.
Yeah, the tree is just the Trojan horse bringing other allergens into your living room.
That is wild. Okay, so sneezes and watery eyes are one thing. But our clinical data from Fair Food Allergy Research and Education and the American College of Allergy, Asthma, and Immunology outlines a much, much more dangerous threat hiding in the pine tree. Pine nuts.
This is where we cross a very dangerous line.
Yeah.
We move from a localized IgE response to a systemic IgE response.
Okay.
Pine nuts, or pignoli, are the edible seeds harvested from specific pine cones. They are delicious, very common in Mediterranean diets, like if you've eaten traditional pesto, you've eaten pine nuts.
Oh, yeah, love pesto.
But if you have an allergy to the specific storage proteins inside a pine nut, the reaction isn't just a sneeze, it's anaphylaxis.
And anaphylaxis is terrifying. You're talking about a whole body immune cascade.
Going back to our analogy, a systemic IgE response means the bouncers don't just try to push the invader out the door. They hit the panic button and call in the biological SWAT team.
Wow.
Your entire body releases massive amounts of inflammatory chemicals all at once. Your airway constricts so you can't breathe. Your blood vessels dilate rapidly, causing a catastrophic drop in blood pressure. You break out in hives.
It's just a total system failure.
Exactly. And you can go into shock and lose consciousness within minutes. It requires immediate intervention with an epinephrine autoinjector to force the blood vessels to constrict and open the airways back up.
It's a literal life or death situation.
Mm-hmm.
And the data shows that tree nut allergies affect roughly 2% of children in the U.S.
A huge number.
What makes it even harder to manage is how highly cross-reactive they are. The notes say pine nut allergies frequently cross-react with peanuts, cashews, and pistachios. Why does the body confuse a pine seed with a cashew?
It basically comes down to the physical shape of the proteins. Antibodies work like a lock and key. They are designed to bind to a very specific 3D shape on the surface of an allergen.
Okay.
But the structural shapes of the proteins in pine nuts, cashews, and peanuts share uncanny similarities. The immune system's antibodies look at a cashew protein and say, that shape is close enough to the pine nut protein I hate, and they attack it indiscriminately.
Which is why the FDA has incredibly strict plain language labeling rules mandating that manufacturers identify 12 specific tree nuts on all food packaging, including coconut.
Right.
But the scariest part to me isn't avoiding a handful of mixed nuts. It's the cross-contact risks. Because these pulverized nut proteins hide in the weirdest, most unexpected places.
They really do. The clinical notes point out hidden tree nuts in mortadella. The Italian deli meat often uses pistachios.
I didn't know that.
Yeah, and you find them in barbecue marinades used as thickeners.
But it's the non-food items that blew my mind.
Uh-huh.
And it brings us right back to the milling and processing we talked about earlier.
Exactly. Those natural exfoliating sponges or body scrubs you see in the health and beauty aisle. The abrasive grit in them is very often made of ultra finely milled, crushed walnut shells.
Oh my gosh.
And the cosmetic industry relies heavily on botanical oils, argan oil, sweet almond oil, macadamia nut oil. They are ubiquitous in shampoos, lotions, and soaps.
So if you have a severe systemic tree nut allergy, just rubbing a natural botanical lotion on your arm can introduce those microscopic proteins into your system and induce a massive reaction.
It perfectly illustrates the paradox of this whole topic. The exact same mechanical pulverizing and industrial milling that makes a plant compound like homobrasolides small enough to be a miraculous medicine also makes walnut shells small enough to become an invisible, life-threatening landmine in a bottle of lotion.
It's all about the context of the chemistry. So let's pull all of this together for you listening. Today's deep dive took you on a massive journey. We started with the apprising muscle-building potential of mustard plants and the hormonal benefits of pine pollen. We zoomed out to explore the incredible medicinal chemistry hiding inside the bark and needles of the Hispaniola pine.
Right.
We dove into the violent microscopic physics of wet and dry ball milling required to make these raw materials bioavailable to our bodies. And finally, we looked at the severe, sometimes fatal immune responses these incredibly specific botanical proteins can trigger when inhaled or ingested.
That's a lot to think about.
It really is. So next time you see a botanical supplement on the pharmacy shelf or a jar of pesto in your fridge, or even just look out at the pine tree in your yard, you'll know the immense chain of chemistry, physics, and biology operating beneath the surface.
And I'll leave you with this final thought to chew on. If simple plant compounds like brasinosteroids can pick the lock of mammalian biology so perfectly, mimicking our hormones without the dangerous side effects, and if pine trees are housing highly specific cancer-inhibiting molecular machinery in their bark, it makes you wonder, what other incredibly specific biological keys are currently just hiding in plain sight, sitting in the everyday weeds, shrubs, and trees we walk past every single day, just waiting for the right milling technology and the right curious mind to unlock them?
It's a great question. Because who knows, the next massive breakthrough in human medicine might literally be hiding in the mustard at your next barbecue. Thanks for joining us on this deep dive. We'll catch you next time.